Good morning. Here I'm there to discuss about our digital search trees. My name is Latika. So digital search trees. So this is also one of the variant search tree in advanced data structures. Generally, we heard about binary search tree, aerial trees, red black trees, and binary trees. So this is one of the search tree that is a digital search trees. So digital search tree is nothing but it is a binary tree. It is a binary tree in which the node contains one unique element. Each node has one unique element. Generally, in the other structures, nothing but a tree structures, it is a collection of nodes, right? So the collection of nodes contains elements. When coming to this digital search trees, the node contains elements, so that is in the form of binary representation. You know that binary representation means the nodes are in the form of zeros and ones. The keys are represented in terms of zeros and ones. So the root node, generally the tree structure has a root node and the children nodes. That is again a left subtree, right subtree. There are many components which comes into the picture when we are discussing about any trees. So in the digital search trees, the binary representation, how the left subtree moving, right subtree moving can be done based on the bit representations. So the bit values is an important thing here. We have to we have to divide the step which we should take the left move or which we need to take the right move. That can be decided based on the bit values. We'll see. This is an example. Here there is an element we consider, that is 1 triple zeros, 1000. So is first bit of the this number or the element, the key is 1, and the other three bits are zeros. Yes, nothing but 1 triple zero. So the whenever you are inserting an element in the tree, you supposed to consider the fixed number of bits in the digital search tree. So the root element is the element which is the first come to picture, which is the first element in the order, that will be the root. After that, how you should traverse to the left, how you should traverse to the right, that can be represented, that can be decided based on the values. So if the pair of the key is begin with a zero element, we should take the left move of the tree. If the digits start with a 1, we should take the right move of the tree. So likewise, we are dividing the left subtree as well as the right subtrees of the digital search trees. Look it onto this picture, we will see how it can be done. So let us take this example. There are number of elements 1000, 0010, 1001, and 0001, 1100, and 4 zeros. These are the elements. This is the actual representation of the digital search trees. Here the 1000 is the root node. If you consider this example, so this root node is the first element which is in the list. So it is inserted as a root node. When you come to this second element, you see all the elements which are in the left subtree are started with the 0 bit, and all the right elements which are started with the first bit are ones. So likewise, we divided the left subtree as well as the right subtree. So when coming to these, what are the components here is nothing but the terms in the digital search trees. This is the root node, and these are called these 4 zeros, and 1100 are the leaf nodes. When coming to the internal nodes, these two in the left subtree or the internal nodes, nothing but this is the root, this is the leaf, means the intermediate nodes which are existed is called intermediates nodes or the internal nodes 0010 and 0001. When coming to the right subtree 1001, this is the right element, internal element in the right subtree. So when coming to the deleting operation, we will discuss what is the deletion of the element when coming to the left, when coming to the internal node, how it is varied, we will discuss. So this is the actual representation of the digital search trees. When coming to the operations, it can support search operation, insert operation, as well as the delete operation. We will see one and one how the search operation can be done, how the insert operation can be done, and how the delete operation can be done. When coming to this, insert operation. Consider these are the elements we are supposed to consider for the insertion. So this is the first element. So I said the first element will be the root node. There is no violations will occur while inserting the root node. Simply we can insert the first element as a root node. Once you come to the second element, third element, so by deciding the left subtree or right subtree is based on the bits we will done. So this is the first element we inserted. Next, coming to the picture, 0010 is supposed to be entered. So while insertion of this element, so the first node is nothing but a root node is nothing but considered as a level 1. So in the level 1, so already the element is done. Now at the level 1, you are supposed to take a decision. What decision you are supposed to take? Left move or right move decision. So for that first level, you have to consider the first bit of your insertion key. What is the key which you wanted to insert? 0010. So consider the first digit, that is a 0 here. So we can insert the element in the left subtree. So after inserting, this will be the tree becomes. Next, you are inserting 1001. So first you should move to the root level. After at the root level, the first digit is to be considered. Why? Because this is a level 1. So first digit, that is 1. So from the root to take a right direction, insert the element here. So this will be the tree becomes now. Now insert 1011. So 1011 start from the root beginning. So after at that level, which digit is to be considered to take the decision? First digit. So what is the first digit of the insertion element? 101. So 1 means right move. Yes, here, but already there is an element. Again at the node, this node we should take again a decision for the left move of the decision 1001 or the right move of the decision the 101. So that decision again based on the bit at the second level. Second level is nothing but second digit is to be considered. What is the second digit of the insertion element? 0. So nothing but from the level 2 you should take a traverse towards to the left. Why? Because at the second level, second digit is to be considered. Second digit is 0 in the insertion element. So to the left of 1001, the 1011 element is inserted. Likewise, we should insert the elements based on the levels. At the levels, consideration of the bits is also an important key role is placed. So this is a 4 zeros. 4 zeros start from the root. First digit is to be considered 0, left. Again, second level, second digit is to be considered. Second digit is also 0. So move to the left of the second node. So like there is no element existed. So simply we can insert the elements. So likewise, we inserted 5 elements in the digital search tree. This is a general insertion operation. Coming to the delete operation. So let us suppose coming to the search, how you will search this element 1001. So you should traverse from the root node. So root node is first of all at this level, the search element is 1001. So we are starting from the root node. So root is compared with the search element. Search element is 1001. So there is no match for this root element with the search element 1001. So simply this element is not the root node. So there is a maybe that is existed in the left subtree or the right subtree, that we need to find out now. So at this level, if you wanted to traverse either left or right, what is the decision you are supposed to take? Consideration of the first bit, because it is a first level at the root level. So what is the first digit of the search element? What is the search element? 1001. So search element is 101 means, so which digit is to be considered? First digit is 1 of the search element. So at this root level, 1 is the first digit means root to right subtree. You should traverse towards to the right subtree. So right subtree, there is an element is found, node element. So compare this element with the search element. So in this case, search element and the node element is similar. So nothing but equal. 1001 found at the level 2. So nothing but element is found. If not, we can say that element is not found. So likewise, search can be performed. So delete operation in the digital search trees. So how the delete operation can be done is, so in the delete operation, there are two cases we can suppose to discuss. In the case one, what happened, the element is to be deleted is a leaf node. So what are the leaf nodes I said? In this example, there is a one left leaf node and one right leaf node. So these are the leaf nodes and this one is the root node, and this node and 1001 are the internal nodes. If you wanted to delete the left of the node, if you wanted to delete right leaf node, so how the tree will becomes? So let us this example, if I are trying to delete this leaf node 1011, nothing but right subtree, this is a right subtree leaf node. So I can simply delete this node. There is no replacing is required because it is a leaf node. So simply we are removing the connection. The child node is removed from the parent. This will be the tree becomes. When it comes to the deleting, a node has the children. So if the node has a children, so if you suppose if you are trying to delete 1001, 1001 has a grandparent and has a child. So if we are deleting the child parent, who is the child here? This is the leaf. So leaf parent we are deleting, nothing but this element we are trying to delete. This element has a children, so this node is replaced with the children. So this, after deleting the 1001, the place is replaced with the children, that is 1011. So the replacement is running in the case of the node has a children. So these are the operations in the digital search tree.